Okay team, welcome and let's talk about software testing, which is a very testable topic in any of the certification exam for cybersecurity, right? So let's talk about testing. Software testing, number one, is not an approach that you do at a later point of time. Whenever you start, uh, you know, uh, gathering the requirement for developing a particular product or a software, that time itself you need to prepare for testing. So it has to go with the entire SDLC, not only on the testing phase. Because whenever you are going to design, because there are some approaches or methodology, right, where the entire production of a particular software, development of a particular software is based on testing. First you make test cases and then you develop the software, and then for each and every module, if the test gets successful, then only that particular module is considered final. So that's a very important topic which you have to always think of. Okay, it has to be inbuilt into the entire SDLC as soon as possible. Now, second thing, software testing can be automated and it can be manual as well. Okay, so basically if you ask me, it's a practical fusion of both these approaches. It is automated as well and manual as well, because in many cases you have to go do manual code review and all of it, and in many cases there are very smart tools coming nowadays which we integrate in testing a particular software. Now in the entire SDLC cycle, right, it is very important that security team is taking care of testing from the very initial phase, and you are involved heavily into if not creating those test cases, because sometimes test cases are prepared by the developers, you have to contribute to that, because testing can be a positive testing, it can also be a negative testing, right? Software testing can be positive testing as well as negative testing. When we say a positive testing, that means all expected inputs for a normal operation of a particular application is what is getting tested. For example, you have a form and you are putting age as one of the field. So you are in this kind of testing, you will be testing the numbers only as age, right? Under age you will be testing as numbers only. But there might be chances that some people might not put age, either they don't understand thing well, or sometimes for malicious perspective it can go differently. So when we start putting in unexpected values for testing, that comes under negative testing. It is for identifying any kind of situations where people are putting in some kind of values because of error, or maybe because of lack of awareness or something. And the second can be because of malicious intention. And when we test a particular application against a malicious use, against a wrong intent, it is also called as misuse case testing. Okay, misuse case testing. So these are important things which you must know beforehand, right? Now whenever you do testing, it is not that you first thing which you need to create is a use case, or you in a normal test language we call it as a test case. So based on your hypothesis about a particular threat on a particular software, you create a documentation which actually talks about, okay, once this particular module is ready, we are going to give it this kind of input, and these are the method in which we are going to provide the input, and this is the expected output from the particular software. And based on that, you have every test use case will also have a unique number. It will have a very unique number. So the more test cases you have for a given environment, it is always better. Okay, now coming on to the testing part. A software can be tested when it is just getting developed, and when a particular software is just under coding, it is not ready yet. that time whatever testing we do, it is called as SAST. Static application security testing. We call it as static because at that point of time the application is testing, it is only in the code form. So till now your application is not ready to be executed, and the testing we do at this point is called as SAST. What all comes under SAST? Number one, your manual code review. Okay, what is manual code review? When the code is manually seen by experienced developers for any kind of syntax issues, any kind of logical flows, and good programming skills and documentation, that is what is called as manual code review. This is a very, very important exercise, because if you are able to identify any kind of vulnerability or bugs at this point of time, believe me, this is very early into the entire software development. So then and there, without wasting any time and effort, you can fix it. So the earlier you are going to identify a particular bug or a vulnerability, it is always good for software development. So that's the number one thing. We do manual code review. For manual code review, there are different approaches we can take. There are certain ways in which there is something called as parallel code review. Or you also call sometimes this as pair programming. Okay, pair programming. There are two people who will be doing the same thing. One will be developing the software, another will be testing it and in the real time. So that's called as a pair programming, or we call it as a parallel code review. Then it can also be that you have 5 developers plus 1 team lead. So this guy will be doing a over the shoulder code review. So that's also one of the kind of style which we have. Or other ways are passing on the code for review by a QA team and all of it. So there are different approaches we can take for manual code review. The most important part you need to remember from this objective is, the earlier you are able to identify the any kind of bugs, that's the best thing. So any good programming practices, any kind of syntax problem, lack of documentation, lack of logic, all those kind of things can be reviewed under this phase. So that is why SAST is so important. Okay, we also do under SAST, we also do something called as binary composition analysis. So in this, the entire software, once the code is ready or the pre-compiled version is ready, we actually go and see what is the composition of this particular software. How much percentage is developed, how much percentage we actually use pre-built code, how many open source libraries are there on all of it. And based on that, it is going to tell you if there is a problem with that. For doing the binary code analysis, we actually use a lot of tools out there, some very, very good tools which are available in the market, right? Then binary code analysis, software composition analysis, these are the kind of things which we do in the SAST. Once the software is ready to run, okay, once the software is ready to run or be executed, the kind of testing we do is called as DAST. Now, one thing is very important to understand. Whenever we were doing SAST, the developer or the tester, you can say senior developer or maybe tester, will have access to the code. He might also have access to the libraries and the kind of platforms you are using, the kind of open source you are using, all of it. So in this case, the tester has more knowledge about the entire platform which they are going to test, or the entire software they are going to test. This kind of approach is called as white box, where the tester has full knowledge about the particular code or the particular software. That's called as white box. So when we do most of the SAST exercise, at that time it is mostly white box, because end of the day you are actually having access to the code, right? But when we go to the DAST, that means the software has now been compiled. And when it is compiled, means it is now becoming a black box. It is looking like a black box. You will not be able to see internal coding of the applications. What you will be able to see is only about the interfaces and those kind of stuff. So at this time, whatever testing is happening, it will be more of a functional testing, stress testing, load testing, first testing. Okay, all these kind of things you will be able to do by running certain kind of script, or maybe by testing the software, by giving it so much of input. All these methods can mostly be automated all the time. So that is where we actually see it as a black box. You will be even the user acceptance test is also coming under test. That's because we are not able to see inside the code. In some cases, let me tell you also one more thing. In some cases, before releasing the particular code to the external people for, let's say, UAT and all, sometimes the developer who are developing that particular code, they also go and test it. That is called as alpha testing. So that alpha testing is done by the developers who know the code and everything. That still comes under white box. But apart from that, most of the part which comes here will be under the black box testing. Okay, so that's one. So I hope you understood about SAST and DAST. Now there are certain different type of testing. As we go along, as the software is getting ready, we test different things. The first thing we test, and very fundamental to any kind of software, is unit testing. So unit testing is nothing but a basic building block testing. That means a particular module is ready and you are going to test it. So that's called as a unit testing. Then comes interface testing. Interface testing. So when we are going to test any kind of interface, let's say a particular dashboard or a particular API or a particular interface by which it is going to work with the hardware or the software, when we test these kind of interfaces, it is called as interface testing. We also see a particular module from an integration perspective. So a specific test need to be conducted for any kind of integration with other software or the hardware and things like it in the development environment, or like in the production testing environment. So that's called as a integration testing. Testing is also performed on a system level as well. Once the system is ready, that is called as a system testing. Okay, now testing can also be performed.
Sir, difference between difference between interface testing and integration based.
Correct. So in interface testing, we are testing the interface. For example, you got a software. Now this software is ready. You want to see the dashboard. All the options are here. I am clicking here. These are the options. These are something that will be coming under the interface. How the interface is as per your needs or not. When we test it for integration, let's say any kind of API integration, what data is actually flowing from application 1 to application 2, how it is getting authenticated, how the microservices are getting connected, how the microservices is going through the let's say authentication gateway and all of it. So that is what is your integration testing.
Got it.
Make sense?
Got it, sir.
Okay.
Thank you.
So then on the system level, and then sometimes what happens is the system is now put into production, and already a production application sometimes go with a major update and or a particular change, let's say. So we also do a testing at the time, that is called as regression testing. Okay, regression testing is done on a particular software which has gone through some kind of change. Earlier it was into production, but now it has gone through some kind of change. So before putting it back into production, we want to be sure there are no vulnerabilities, right? And that is what we do in the regression testing. Now while testing these kind of regression test use cases, sometimes we go with partial approach because time is less and you want to partially test the particular code. You can also go with full because something is very very critical, you don't want to take chances, you can go with full, or sometimes you can also take a prioritized approach. For example, let's say only one module has been undergone changes, so you only test that particular module, so it's a more of a prioritized approach. Or maybe risk based approach, sometimes where the risk is high you test it more. So that is one. I also want to talk a little bit about the first testing. A first testing is a kind of testing, more often a black box testing only, in which a particular application is given with a huge amount of or huge volume of fuzz. What is fuzz? It is garbage value. Garbage value. And by putting in fuzz in huge quantity, we want to check the security behavior of the particular application. And this particular security behavior will give you, believe me, sometimes very very weird behavior of the software, and then you can go and fix it. But the way you are going to put a fuzz is also very very important. Sometimes the fuzz which we are going to pass it on for testing, it is called as mutation fuzz. When you create some fuzz data from an existing data, let's say from old time what was being used on the application, you refine it or you change it, you make it fuzz and then pass it on to the application, it is called as mutation fuzz. Sometimes we also have tools which can generate fuzz, so that is called as generative fuzz, or you can also call as intelligent fuzz. Okay, so sometimes these are the kind of things which we are testing. Whenever we are testing a particular application, we test it strongly for any kind of input validation. Input validation. Okay, now what is input validation? When an end user is entering some data into this, let's say name, and we check it if this particular string or this particular data is inconsistent of how this particular test field has been designed to accept, that is called as input validation. So we need to have input validation both on the client side, where the application will be hosted and the user will be providing their data, it has to be tested there as well. It has to be tested on the server side as well. Very very important, because sometimes this client side input validation thing can also be compromised by using certain malwares. Let's say something has been validated first, and later on when the data is getting submitted, that time there is a data diddling, there is a change in the data which is happening, so that can be a risk on the client side. So we need to also make sure that the same validation also need to be executed on the server side, because server are normally placed in a much more secure environment. So that is also something very very critical. Okay, so that's about your input validation. As part of the input validation, whenever we are doing input validation, always follow whitelisting approach. Now what is this whitelisting? Whitelisting means denying everything by default, and then only allowing those strings or values for that particular range which we are going to use or which you want to apply in the input validation. That is called as whitelisting. So whitelisting should always be followed as a simple principle. We also do bound checking. That means boundary checking. And for boundary checking, let's say I want to have a particular application and there is a field in there which is actually capturing age, and let's say this age is from 18 years to 40 years. Now as a field, anybody can put any age. People can put it 1.5 as well, people can put 200 as well, people can put an age or anything as well, 99999 as well. So we have to partition this entire data value which we are going to accept. So what we do, we divide this entire number range into different ranges. So any kind of number before it, any kind of number after this, We need to have rules defined for that, so that we only accept the data which is within this particular range. This is called as boundary, or this is called as value parameter. So while doing bound checking, we also do it. Okay, sometimes we also check the boundaries also very fine. For example, just consider in this particular case, somebody might put 17.99, and user and the system might accept it because it is 99, system may take it as 18. Same case can happen here as well. So when we fine grained go to that level and check the boundaries of these numbers here and this number, that is called as boundary analysis. So not only other checkings, we have to do the bound checking for these things as well. So I hope this gives you a good insight into the entire stuff, right? Now, very important, once you do a software testing, normally there is a report which is released, and in this report, a very important section of this report is something called as test coverage. This test coverage is basically a matrix to understand how rigorously a particular application has been tested. For example, a application has 1000 lines of statement, right? 1000 lines of statement, and your use cases you have tested against that, they could only cover 500 statements. So 500 divided by 1000 in 200, that means 50% is your test coverage for the statement. Same case, we tested for you can say any kind of decision boxes as well. We also check it for branches as well, because software flow we have different branches, yes, no, all of it, they also can be tested, and so on. So that's called as your test coverage. So I hope, guys, I have covered software testing end to end for you for your CISSP exam. I think this one video should be enough for you. I think everything covered into this one single video.
Sir, what
Okay,
about
guys.
component testing? What about component testing?
So there are a lot of many other testing as well which we can do. There are some testing which are happening for libraries, there are components and so many other stuff. But from a CISSP perspective, these are the kind of things you should know. That is what I have covered right now. Okay.
Okay, sir.
Otherwise, it can take another 2 hours for me to keep speaking about testing, right? So that's how it is.